so this is problem 5. Problem 5 reads, approximate the area of the region under f of x equals 2 divided by x on the interval 1 to 3, including 1 and 3, with a Riemann sum using 4 subintervals of equal width and letting x sub I star be the left endpoint of the subinterval of x sub I minus 1, comma x sub I. Okay, so first of all, we want to find the area, right? So let's look at 2 divided by x. So let's look at this visually. Okay, 2 divided by x from 1 to 3. So here's 1, and here let's say it's 3. And 2 divided by x is pretty much 2 times 1 divided by x, and 1 divided by x looks like this. 2 just means you are compressing it horizontally. So let's see, if you plug in 1 for x, you'll get 2. So here we have 1, here we have 2. So here's my starting point. And if you plug in 3 for x, you get 2/3. So it's something about here. So we get something that looks like this. Something like that. Okay. So that's what we get. Now what we want to find is we want to find the area under here. So we want to find all this area. But we want to approximate it. And we want to approximate it using left endpoints. Okay? So, and we want to use 4 subintervals, correct? Yes, 4 subintervals. So what I'm going to do is I'm going to find the midpoint between 3 and 1. The midpoint between 3 and 1 is 2. So roughly about here. And now I want to find the midpoint between 1 and 2. So let's find midpoint 1. So the midpoint between 1 and 2, how do you find that? We'll add up the x's. 2 plus 1 over 2, that's 3/2. So the midpoint there is 3/2. And likewise, for M2, it's going to be 5/2, because the midpoint between 2 and 3 is 5/2. How do you do that? You get 3 plus 2 over 2, that's 5/2. So that's our midpoints there. Now we have 1, 2, 3, 4 subintervals of equal length, or equal width. Okay, so we want to use the left endpoints. So we start here, and we go ahead and draw a rectangle, like such. And then we start here, so right there, and we do another rectangle. Then we start here, do another rectangle, and we start here, and we do another rectangle. So approximately that will be the area. Obviously there will be some error because we have this that's not under it, but it's fine, we're just approximating. Okay, so to find then the area of these 4 rectangles, we just got to multiply length times width, or width times length, right? So what do we get here then? So we get area then is equal to, okay, this little piece right here is going to be 1/2, and it's actually going to be 1/2 for all since it's equal width. Okay, so we have a 1/2, right, times, now we want to find this side, but we already know that this side length is 2, so we're going to go ahead and multiply that by 2. Alright, that's fine. So now we have the area of just this rectangle. Okay, now we want to add the area of this rectangle. So plus, okay, then we already know that this little piece is 1/2, because they're 1/2 for all of them. So that's another 1/2 there. By the way, the area of a rectangle is length times width. That's what I'm doing. So this times this. Now I'm going to do the 1/2 times this one. Okay, to find how much this length is, all I have to do is plug in 3/2 into the function, and I'll get the y value. Okay, so then f of 3/2 is what? F of 3/2 is going to be 2 divided by 3/2, so that's 4/3. Okay, so we have 1/2 times 4/3. Okay, so that's the area of this rectangle. Now, we got to add it to the area of this rectangle. Okay, so what's the area of that rectangle? Well, the width is 1/2. Okay, and now the length, same thing. We're going to go ahead and plug in 2 into the function. So f of 2 is what? 2 over 2, 1. we have 1/2 times 1. So now we have the area of this plus this plus this. We're missing this area. Okay, so we're missing this area. Again, that's plus 1/2, because that is the width. And now to find the length, plug in 5/2 into the function. Let's plug in 5/2, f of 5/2. That's 2 divided by 5/2. That's 4 divided by 5. So this is 1/2 plus 4 divided by 5. Okay, so now we have all that. The area then is, we have 1/2, 1/2, 1/2, 1/2, common factor that out. So factor 1/2 out, we're left with 2 plus 4/3 plus 1 plus 4/5. Okay, so now I'm going to add the 2 and the 1. So I'm left with 1/2, 3 plus 4/3 plus 4/5. Okay, now that I have that, I'm going to go ahead and distribute the 1/2 again. That's how the answer wants it. So distribute the 1/2, so I get 3/2. Distribute again, I get, if I distribute the 1/2, the 4 will cancel with the 2, so I'm left with 2/3. So plus 2/3 plus, if I distribute the 1/2 again, we're left with 2/5. So that is the area that they want. And they just want it like that in the answers. So the area is 3/2 plus 2/3 plus 2/5. Okay?